Hey gang, welcome to week 6 of Code Club Year 2. This week, we're going to make it so that you can actually interact with the spiders, and make it so that when you pick up a coin, it adds a score to the screen. Open up another browser window and log on to Cloud9 so that you can follow along. Have fun and let's start coding. When we left off last week, we had coins and spiders, but they didn't really do anything. We picked up coins and they didn't do anything in the game, and we didn't interact with the spiders at all. So this week we're going to make it so that if we pick up a coin, it adds to a score for the level, and we're going to make our enemies more dangerous. If we run into a spider, we're going to make it so that it kills us, and if we stomp on a spider, we're going to make it so that we kill the spider. The first thing we want to do is make it so that when we stomp on a spider, it creates a sound. And how we're going to do that is we're going to preload a sound just like all the other sound preloads. So in Create, when we create the list of sound effects, we're going to add a new sound effect called Stomp there. And then up in Preload with the other audio assets that we're preloading, we need to preload the wave file that has the Stomp sound in it. Now that we have the sound in place, we need to add a collision between the hero and the spiders. And this is going to go down and handle collisions like all of our other collisions. And it's going to look very similar to the collision between hero and coins that we already have, where it's an overlap collision, and we call a new function called onHero versus enemy. And of course, that onHero versus enemy function doesn't exist yet. So let's scroll to the bottom of our file, and we'll add that function. The interesting part about the onHero versus enemy collision is that there's two different types of actions that we could take. The first one is if the hero is jumping on top of a spider, we want the spider to die. The other option is if the hero runs into a spider, we want the hero to die. So we have this if test in onHero versus enemy, and the if test says if the hero's Y velocity is greater than 0, then the enemy dies. And the velocity on the y-axis being greater than 0 means that our hero is up in the air, and that means he's in the middle of a jump, he's jumping on top of the spider should die. Otherwise, if he's just running, his y velocity is 0, then that means the hero should die, and right now all we're going to do is have the game restart if that happens. If you're paying close attention to our code, you might notice that there's two function calls here, hero.bounce and enemy.die. And neither of those functions exist yet on the hero or enemy objects. So we're going to have to go back and add those now. The first one, hero.bounce, all it does is it adds a little animation to the hero object when it kills the spider that makes him look like he bounces a little bit. It's just a little animation we added to make the game a little more lively. It's nothing special. And all it does is it changes the Y velocity just a little bit so that it looks like he bounces. The spider die function is a little more interesting. We'll add it down here. So what this does is, the first thing it does is disables the spider from having anything interact with it. And the reason we have to do that is because if we don't, because we're still going to play an animation yet on the spider, the hero object would keep interacting with it, and we don't want that to happen anymore. It also disables the spider from moving, all sorts of stuff like that. So we need to disable it first so that other stuff can't keep happening to the spider. Then we play the death animation that was added in the previous session. And we add this cool function to it called onComplete. And basically what it does is it plays the death animation. And when that animation completes, it runs a function. And the function we're having it run is this.kill, which if you remember from last time, this.kill is a sprite function that kills the sprite. It removes it from the game world so that nothing can interact with it. So this is how we get rid of a spider on the screen. We play the death animation and then we kill the sprite so that nothing can interact with it. Now if you save your code and go back to the preview window, we move around, we can interact with spiders. So they kill us, it restarts the game, but we can also kill them. And you see that little bounce action that it does? I'll do one more so that you can see it better. There's that little bounce animation on the hero right after it kills the spider. Just something else to make the game look cool. Now that the spiders do something, we need to make the coins more useful. And the way we're going to do that is we're going to keep a score of how many coins the hero collects in a level. To do this, we need to keep track of how many coins we're collecting. Right now, when we pick up a coin, the coin just dies off the game and we don't actually keep track that we collected any coins. We also need a way to display text and numbers on the screen to be able to say, hey, you've collected this amount of coins. And then also we need like a special area on the screen to display that number of coins collected text, because we don't want the hero or the spiders or the coins or anything else to be able to interact with that area where we're displaying text. Otherwise it would screw stuff up in our game. The easiest part of what we need to do is adding a counter for how many coins we picked up. So let's switch back to the code. And in the playstate.init function, right at the end, we're going to add a new variable called coin pickup count. And we're going to initialize it to 0 before the game starts. So coin pickup count is going to increment every time that we pick up a coin, and it's going to start at 0. So you always start with 0 coins. Then we need to have it so that when a hero picks up a coin, it actually increments this counter. So let's go down to our onHero versus coin function, because that's the logical place to increment the counter for when a hero interacts with a coin. And we'll just add this code here that says coin pickup count plus plus. Now this is a kind of a weird looking operator, and it's basically the equivalent of saying this dot coin pickup count equals this dot coin pickup count plus 1. It's a shorthand way of adding this code. Lots of programming languages have it. JavaScript is one of them. That almost every programming language has this plus plus operator that just means increment by count by 1. And so that's what we're going to use. We're not going to use this longer version of it. The next thing we need to do is add an area to our game to display our score. In gaming, the area of the screen where you display your game's vital statistics, like the score or a number of lives remaining or the items in your inventory, stuff like that, is often called a HUD. It stands for Heads Up Display. It's a term that they borrowed from aviation, where a pilot has a screen in front of them that they call a Heads Up Display, and it has a bunch of information on it. Part of our HUD is going to be, it just displays a coin icon, and we need a new image for that. So we're going to go up into PlayState Preload, and we're going to add a new image here that's a coin icon. The next thing we need to do is actually create the HUD, and we'll add some code. Down near our spawn things, we'll add it after spawn enemy wall. We'll add a new function called create HUD. If we look at this code a little bit, the first thing we have is we create that coin icon that we preloaded before. This is a little different than some of the previous ways we've added an image to the game, and that's because previously we've always added the image directly to the game world. I think the best example of that is the background. We used game.add.image and then the game background. Here we're saying game.make.image. And the reason we need to do this is that we're going to add the coin icon into a group called HUD. And if we added it to the game world, then it wouldn't be in that HUD group, it would just be in the world. So because we want it to be in the group, we have to add the coin icon with the make statement instead of the add statement. Then we can create the HUD, and here is where we say, in the HUD, add the coin icon. So that means that the coin icon is part of the HUD group. It's not part of the overall game world. But the HUD group is part of the overall game world. So that's how we kind of reference it. We have to reference that coin icon through the HUD group from now on. The last thing we do is we set the position of the HUD to be 1010. And the interesting thing about the positioning of a group is that all objects in a group, so, we put that coin icon into the HUD group. The position of that coin icon is relative to the HUD group. So if we place the HUD group at 1010 like we're doing here, and then we say that the image is going to be at 00, that means that the image is actually also going to be at 1010. But if we had done this differently, if we had said the image was going to be at 55, that would make it be within the overall game world, because it starts at 1010 because of it's in this group. Then the coin's position would be 1515 because it's additive. It adds 10 to 5 and it starts it at 15. But we want it to be at 1010, so that's what we're gonna change this back to here. The reason we do this, the reason that we have a group called HUD and then we put the coin image and then in the future we'll put other HUD elements into it, is if we wanted to change the position of the entire HUD, all we need to do is change this position. The coin icon and the position of all the other elements within it will change as we change the position of the HUD element. That's what it means to have relative positioning. So if we change this to be 100, 100, and this has position 0, 0 within the HUD, then this position will also change itself automatically. We don't need to do anything to be 100, 100. Now that we have the code to create the HUD, we can actually add it to the screen. And the way we do that is we go up to playstate.create, and at the end of it, we add the code for this .create HUD. So when the creation happens, it's going to create the HUD. Interesting thing about JavaScript here and Phaser is that when things are added to the screen, the how they display on top of each other is in the order that they get done. So we have, game add image background, and then we have create HUD. If we had create HUD before the background load, that would make the background load on top of the HUD, and we wouldn't be able to see anything in it. So we kind of need to be aware when you're adding elements to the screen, how they interact. If you have something that looks like it's on top of another thing and it's not supposed to be, you probably need to change the order that they're loading into the game. If we save our code and go back to the preview now, we should have a big coin icon in the upper left of the screen. So the HUD starts at 1010 and the coin icon is 0, 0 within it. So this coin starts at 1010. That looks about right. So the coin icon image is now part of the HUD. Now we need to add what's probably the more interesting part of this, the actual count of how many coins we've picked up to the HUD. And there's several ways to display text on your game in Phaser. We're going to use a technique that Phaser calls retro fonts, but the rest of the world calls bitmap fonts. And the way that they work is you load up a sprite sheet. If you remember the talk from last week about sprite sheets, it contains all the text you're going to display. In our case, it's going to be the numbers 0 through 9, a lowercase x, and a blank space. And then you add a retro font object that tells Phaser what sprite sheet to use, what characters are in the sprite sheet, how to identify them within the sprite sheet, how big each character in the sprite sheet is, and it uses all that information to be able to display text on the screen. It's a real simple way of doing it. You wouldn't want to do it if you had like the entire alphabet and all the numbers and emojis and all the different weird stuff you can do with text. You wouldn't want to have all of that stuff loaded up using retro fonts, but for the 11 characters we're displaying, it works fine. The first thing we need to do is preload the image for the sprite sheet, so we'll add it down here. One weird thing is, while I keep saying it's a sprite sheet, we load it as an image into preload. And the reason we do that is because the fact that it's going to be loaded as a retro font object, retro font takes care of all the stuff that loading it as a sprite sheet would do for us. So we load it as an image here, and then we create a retro font object, and that's what tells it to be a sprite sheet. Now we can go back down to the create HUD function. And in here, right at the top of it, before we do anything else, we're going to add the code that adds the retro font. And there's 2 lines of code here. The first one, it tells the retro font what characters are actually in the image that we're loading. And it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, an X, and a space. The second line of code is what actually creates the retro font object. So we create a coin font. It's a retro font, and we tell it we want to use the image that we preloaded above called font numbers. We tell it that each individual sprite within the sprite sheet is 20 by 26. We tell it what each individual icon looks like. And one thing to note is that the order of these is important. If we had 1 and 0 switched for some reason, then when we try to load a 0, it would load a 1. If we tried to load a 1, it would load a 0. So the order of this has to match what they look like in the actual image. So if you look at the numbers image, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, X, and blank. So this has to be the same order that we show in this number string. The last number here, this number 6, it tells the retro font object how many characters there are per row of the sprite sheet. This is not something that you actually have to put in there, but it makes your processing just a little bit faster. And when you have a game, having it load up fast is something that people want. So it's a little, processing thing that you want to add on there to make your game a little faster. Now we can actually add the score image into the game. And we do this by, we're going to create a new image here. And we're going to do a game make image. So that's going to add it to the game, but not put it in the game world because we want it in the HUD. And this line looks a little bit weird because there's some math going on here. But basically what it's saying is we want this image to be directly to the right of the coin icon, and we want it to be directly in the middle, up and down of the coin icon. And then the image that we're going to use is this coin font that we created up here. So it knows it's a retro font because we're adding it as a retro font up here. The second line sets the anchor to be the left side, but halfway up and down the middle. And that's to assist with putting it halfway into the up and down of the coin icon. Then now that we have the score image, we can add it to the HUD group. The last thing we need to do is make it so that when the game updates, it checks how many coins we've picked up and updates the HUD with this is the number of coins you've picked up. So let's go up to our game update function. Remember, this is the one that runs really fast, 60 times a second or whatever. And we're going to add this line of code to it that says this.coinfont.text equals this kind of weird looking line of code. So the first part on the left side of the equal sign, it says this.coinfont.text. And coinfont is our retro font, and it has a property called text. Whatever is in this text field is going to be what's displayed on the screen, as long as the characters in it are something that are in our sprite sheet that we have. So we need to make sure that whatever we put in here is part of the sprite sheet. The problem with this is that we don't actually know the score, the number of coins that have been picked up, as a piece of text in our game. Instead, we're going to have to use a trick of JavaScript called template literals. And what that means is we can put some code in here that makes JavaScript look at a variable and make it some text so that we can assign it to something. So the first thing you'll notice is that surrounding our template literal are what they call backticks or grave quotes, or grave quotes, I've heard them called sometimes. They have a bunch of weird names, but I'm going to call them backticks. And so a normal quote is the one next to the enter key. It's straight up and down. It looks like that. The backtick quote is next to the one key to the left of it, and it kind of looks backwards like that. And that's the one we're going to use. And the way it works is any plain text that you put in there is just going to be part of the text on its own. So this X is in there, it's just going to be interpreted as an X. Anything you put within the $ followed by the curly brace, so like this, that's going to interpret as, read this as a variable and interpret it into text. So this is going to look at the coin pickup count variable, which is where we're storing how many coins we've picked up, and whatever's in here, it's going to turn into text. So if we've picked up 5 coins, this is going to display as X5. If we've picked up 100 coins, it's going to display as X100. But you need to make sure whatever's in here is something that can be displayed as part of our retro font, because we only have 0 through 9, the X and the space. If we save our code and reload now you can see it says it's got the image for the coin, and then it says X0 because we haven't picked up any coins. But now every time we do, this updates, and you can see 0, 1, 2, 3, 4, 5, 6, 7. So now our HUD is updating with how many coins we've picked up. This week we added some cool things we can do with the objects in our game. We added the interaction with the coins and the spiders, but there's really no objective to our game. Next week we're going to add a win condition for each level, which is you're going to be able to pick up a key and go through a door, and then make it so that when you get to that win condition, you go to the next level. So that'll be next week on Code Club. Alright, that's it for week 6. I hope you enjoyed it. We'll see you next week.